Hello and welcome to another episode of Allot 360. I'm Michael Schachter, Product Marketing Director at Allot, and I'm here today with Yaakov Stein, the CTO of the Allot Smart Business Unit, and we're going to talk about 5G, non-standalone, standalone, what's it all about? So Yaakov, what is it all about? Why do they call 5G non-standalone?
Okay, what we're seeing right now is mostly non-standalone 5G. Now, what does that mean? Well, most people, when they think about mobile networks, they only think about their device and the base station, which is called the G node B in 5G terminology. However, the majority of the mobile network is not the air interface, the part in the radio, because you have to connect up all those base stations to a core network. And the core network is what allows you to go out to other networks, either the internet or a data center, or of course connect telephony calls to other mobile networks or fixed networks. So we have this core network and what's called the RAN, the radio access network, which starts from the user device and goes all the way to the core. So these are two separate parts. In non-standalone mode, only the radio access network, the RAN, is changed. The core remains the core of 4G. So basically, you get higher speeds, you get some reduction in latency, but a lot of the goodies in the core you don't get. Now, I have to explain a little bit about a core of a mobile network. Unlike an internet core, the internet core is a dumb core. It's basically a bunch of dumb pipes. But telephony cores, and especially mobile cores, are intelligent cores. They have a lot of functionality. For instance, they have to track a user, know exactly where he is at any moment so that they can direct an incoming call to that user device. So there's a lot of smart functions. And 5G changes the core in a fundamental way. The core is now made of network functions rather than network equipment. Network functions are simply pieces of software which are embedded in a cloud infrastructure. Now, why does the 5G core use cloud native infrastructure? For one simple reason. It's the only technology we know of that can scale up indefinitely.
So if the 5G core is so much more expandable and intelligent, and service providers have spent so much money on spectrum and deployment, why did they do it in steps? Why start with non-standalone and then only later finish the work and give you end-to-end 5G? Why this interim process?
That's a great question. Why did they change the RAN rather than changing the core as a first step? Well, it was easier. It's not cheap. As we said before, they had to spend a lot of money on spectrum. But the core is a fundamental change in the way a mobile operator has to work. A mobile operator who adopts a cloud core now becomes an IT company. And that mobile operator now needs IT staff. All of the people who know how to run network equipment are no longer that relevant. So you have to reinvent yourself as an IT company rather than a mobile operator, or as in addition to being a mobile operator. And that change takes a long time. It's a culture change.
Okay, but it's still something that they want to have happen. When can we expect this migration to standalone to actually happen? Because it sounds like we've got this great, radio peripheral interface, but then you're still stuck with the old 4G core with its limitations.
Sure. Well, we're getting more bandwidth, which is good for people with smartphones. But let's remember something. 5G is not about people with smartphones. We didn't really need a new generation to give us another factor of 10 or even 100 speed up. 5G is about devices. 5G is about IoT. Now, in IoT, there's more than one kind. There's the kind for critical infrastructures, which has really low latency and high reliability, what's called ultra-high reliability. And there's the massive kind, where you need lots and lots of devices. Those applications are the applications that are going to give the return on investment to the mobile operator. But they're really not there yet. So right now, the mobile operators are spending a lot on spectrum, a lot on their upgrade, and they're trying to recoup it using several stopgap measures, such as looking at private virtual networks, which are called PVN in the 5G lingo, rather than VPN. Make sure you understand the difference. Why are they doing that? Because traditionally, mobile providers and all telecommunications service providers get higher revenue from enterprise and business users than they get from residential or mobile users. So an initial stage is these private networks, but that will only go so far. We're sure we're going to get the standalone networks because otherwise it doesn't work out economically. But it's going to take some time.
Okay, so we will wait for the standalone networks and make do with the non-standalone interim
Can
solution.
I just say one word about how much is really out there? I think we sort of implied that everyone knows these numbers. Right now, we're seeing about 10% of the new network deployments employing standalone. 90% are still non-standalone. We expect by the end of this year, 2023, only to see about 30 standalone 5G networks, real standalone 5G networks in the world, worldwide. And the rest are going to be non-standalone, but it's got to change. We're sure it's going to happen.
So the change is coming, but in the interim, and it'll be a non-trivial interim, there will be a lot of non-standalone networks with the limitations that the 4G core imposes on the end-to-end traffic. How can Allot help service providers get better utilization out of their non-standalone networks until such time as standalone comes around?
You're quite right that in this interim, all we're getting is faster speeds in most of the world, right? However, the goodies that I mentioned before in the 5G network require this upgrade. Now, one of those goodies is something called slicing. There are two kinds of IoT devices, the kind for critical infrastructure in Industry 4.0, and the massive ones, which we'll need for smart city and things of that sort. And these two kinds of IoT applications are going to be coming down the road, but we still want to put all of these things, the mobile broadband and the two kinds of IoT on the same network. We're not going to build separate networks. And this brings about the idea which is called slicing, which means building independent, hard isolated networks over a common infrastructure. We don't have that yet because we need the core for that. So Allot can come along and give what we call soft slicing. Based on our traffic identification and traffic management and congestion management, we can give a lot of the features of real slicing without going to this new core.
So it sounds like Allot has an important role to play, and it will be substantial, and it'll be around for a while, helping the service providers provide these virtual soft slices for all kinds of applications and services.
Allot can help a lot.
Thank you, Yaakov, and thank you all for being with us, and I look forward to seeing you at the next episode of Allot 360.